Lawrence. Thanks everyone for joining our the role of waterproofing and energy efficiency. I'll get right into it. So a little bit about me. I actually have an IT background, but I'm now been in construction for about 18 years. So I've seen the ins and outs of waterproofing over the past 18 years. I'm in charge of strategy, sales and team development for Danrae Group. I'm the CEO, and I'm a builder and waterproofer, licensed waterproofer, and I'm also a registered building practitioner under the DBPA. That is a photo of my lovely family there, my two little girls. Eldest is Lily and youngest is Chloe, and my beautiful wife Rosa. And I am not to make anyone fearful, but I am a blue belt in karate. I am the I'm on the committee of ACRA, the Australian Concrete Preparer Association, and also the Strata Community of Australia. Little quick spiel about Danrae Group. So we're a specialist remedial waterproofing contractor. We're a builder, and we focus on water leaks into flat roofs. That's our main core business. However, we do a lot around the remedial industry, about leaking balconies and podiums, etc. And that's these are a couple of pictures of what we do. So just quickly. All right. I'll skip these. No, there we go. And a big welcome to our guests, Lorenzo from Good Earth. I'll leave it to you, Lorenzo. You want to do a quick intro?
Yeah, thanks, Daniel. So my company, Good Earth, we specialise in electrifying buildings. So we focus on energy efficiency. We're currently undertaking quite a few projects at the moment. So we're doing solar for apartment users. We're doing heat pump upgrades. We're doing EV charging into strata buildings. So we've sort of got quite a few of those projects happening right now as we speak in Sydney. And we've worked with Daniel when Daniel's done some remedial work on buildings. So we can talk about those things. I'm very passionate about energy efficiency. I'm also a girl maker like you, Daniel. I've got 3 daughters. Mine are slightly older than you. And I've always wanted to get a martial art. So one of those things I should go do. But I'm passionate basketballer. So yeah, that's a little bit about me. And yeah, my passion is sort of energy efficiency and electrifying everything. So
nice. All right. Thanks.
Yeah.
Thanks a lot. Thanks a lot. So today, what are we going to be talking about? So we'll be talking about how waterproofing supports energy performance, in particular on roofs. That's where the most exposure is in its interaction with other building elements such as insulation and solar panels and HVAC. And I'll introduce something called the solar reflectance index and cool membrane. So not a lot of owners and building managers know about this. So I'll talk about that today too. And just some practical examples and some design tips that also Lorenzo will chime in on too with regards to building design and making it a bit more energy efficient. So a couple of a big stat is, buildings are 40% of the global energy consumption. So how we design and control the use of energy is really important, in particular with thermal, especially on the thermal control on energy on your roof, being quite a large surface area of the building envelope. It is one of the major factors that you can use to actually reduce your energy consumption. And what a lot of building designers and owners don't know is the intrusion of moisture into the roof really undermines that efficiency, which I'll talk about in the following slides. So specifically on waterproofing, its role is obviously to keep the roof dry, but also depending on the design and where insulation is placed, it also protects the insulation and ensures it's dry as well. And it prevents a lot of leaking of obviously water, condensation, and extends the lifespan of the whole insulated system. I've got a photo. The diagram on the right there shows you a typical design where the insulation is over the membrane. That is actually energy efficient. The issue is that on a lot of older buildings, the insulation unfortunately is sometimes absorbs the water and also allows water to track between the joints and settle on the membrane. So what can happen is energy is more heat is more easily transferred to the slab, to the concrete slab. So I will go through a couple of designs following to sort of show you more energy efficient designs as well. So solar reflective membranes. So a couple of terms here. So SRI, meaning solar reflective index, and thermal emittance improve the I suppose energy efficiency of a roof. And the SRI is measured from 0 to 100 or over. And you can, the suppliers can actually give you those ratings on their membranes. And it also, solar reflective index is an indicator of, it actually directly lowers the energy use, or is, can be directly correlated to the energy use on a roof as well. Lorenzo, I don't know if do you deal with the solar reflective index in your energy assessments on a
look, it's one of those ones where the reason we do what we do is because buildings in Australia are thermally inefficient. So having a thermally efficient roof can dramatically reduce the heating and cooling load on that top floor of the building.
Right.
And so it does correlate, because an inefficient building means I have to oversize solar, I have to oversize equipment. Everything's dealing with a heat load or a cool load, so the equipment is all trying to deal with the fact that the building's inefficient or can't, disperse energy, or in your case, with a really good membrane there, and a light colored one, you can reflect a lot of that heat load off the roof. So there's a lot of information out there on not just these roofs, but even on metal roofs now, where they're putting those reflective membranes on, and it's making a dramatic decrease in thermal heat load. So it's very important.
Great. So this diagram I was just showing you what is SRI. It's the reflective index of the membrane that's being put onto the roof. And as you can see, this design, the membrane is actually exposed and it's protecting the insulation. So with those combined factors, and the R rating of your insulation will then improve the overall energy efficiency of your roof. Right. So, and then essentially following that, the energy consumption of the building. So that's sort of just to show you what that looks like. With regards to SRA ratings specifically, these are sort of the rough indicators of various membranes that you'll see on a roof. The membranes that will tend to be used on a roof will be your PVCs and TPOs, FPOs on a roof. So you'll get that range of 82 to 110. When it's light grey, while it's very close to it'll be pretty close to the white on a sheet membrane on a PVC, but it's not as good as a white. However, the white is obviously the most reflective. Torch on, as you can see, it's quite low because it's a black. It is black, but the granules, what reflects the heat is the granules that are actually on the top layer of the torch on. They do offer some reflective index, but once they start to wear, the reflective index is gone. It'll start to diminish. And then you've got your liquid coating. So a white acrylic coating will be quite reflective as well. But unfortunately, any sort of liquid membrane, things like that you cannot use to cover your insulation. It just won't work. So generally speaking, the roofing that we design, you've got your insulated panel and a PVC or sheet membrane protecting that layer. So quick case study. This this project was a roof that had existing pebbles over the roof, and the whole roof was leaking. What we did with this roof is we removed all of the pebbles and installed a insulated panel system with a PVC. This membrane here was a Fatra PVC membrane over the top. Hopefully you can see that video. So yeah, you'll just see the drone flying around.
It looks fantastic compared to the one next door, mate.
Yeah, so that's the completed project there. Yeah, so obviously the owners were quite happy with the difference in temperature is actually quite surprising, especially in the top level. You'll get a big difference in the temperatures in both using the insulated system. You'll get quite a big difference in summer and winter in the cooling of the units,
which should positively reflect in their power bills by not having to run the aircon as much.
Yeah, that's exactly right. So and that's just giving you a close-up of the detail. So you'll notice also the anchor points too. So the anchor points on the roof are very important, in particular on how they're installed, because when you do the anchor point tests, they can actually crush the insulation when they do the testing as well. So you have to make sure that's all installed correctly. Okay, so working with insulation. So obviously with wet insulation, it's not going to perform simply because water will then transfer heat directly to the slab. So you cannot have wet insulation. That will completely diminish your thermal benefit. Closed cell insulation will obviously block moisture from being absorbed, and then overlaying the membrane over the insulation protects water from entering any joints, as well as the insulation integrity overall over the lifespan of the membrane. This is a quick table of the various R values. So the higher the R value, the better the energy efficiency. So the typical insulation that you would see on a roof would be your rigid foam boards, right? So I'll go into the types in a second. The other insulation types you'll see over various building types. So obviously fiberglass bats, things like that, you'll see in a standard home in the roof. Spray foam is also used in houses. Mineral wool and reflective foil. It varies. Different projects will use different types in there. These are the common ones that we see in insulation types. Your PIR and your XPS boards are the most rigid. Rock wool, not so much. We don't see that used on roofing. It's the most superior with regards to fire performance, but it's not very good on a flat roof because it's not very. It has very low compressive strength. So PIR board and XPS are the two we see the most of. On a roof where there's a lot of foot traffic, we'll tend to use the XPS because it's the most compressive strength. However, it's not as thermal. It doesn't give you as much thermal performance. Lorenzo also mentioned metal roofs. So in this particular design, it's a metal roof with insulated infills into the profile. And then what we do, we then install an insulated panel over the whole thing, and then it's protected by a membrane. So that increases your thermal performance of a metal roof, and also increases the durability of the roof as well. So if going from a metal roof 10-year lifespan warranty to up to a 20-year warranty, but then the lifespan's even further than that. So that's actually that's a couple of projects now that we're installing the metal roof design as well.
How much would you say the R values increased, Daniel, there on that? Because that looks like to me it's going to be an amazing increase.
Oh yeah, so you'll get it depends on whether It depends on whether you've got insulation underneath the metal roof as well. So, but generally speaking, we'll get oh geez, like a that board, you'll get an R value of like 6 R value 6 just in the board, and then you'll get, and then the reflective index of the membrane then increases reduces the heat reduction. In the heat absorption into the roof as well.
Yeah, that's fantastic.
Yeah, so so the other factor is not necessarily energy efficient, but you'll get, when doing this design, it saves you removing the metal roof. So that way you don't have to worry about disruption to owners and whatever beneath the metal roof. But yeah, that's a system we're installing now, and it's a quick video show you as well of that. Just shows you the layers going down on the metal roof. So we actually infill the profile with insulation, so there's no gap in there, right? So so you'll see the insulation going in, and then the boards, another layer of boards go over the top of that as well. That's that. All right, supporting solar systems. So solar. So we see a lot of buildings obviously moving to this now. The issue with solar often is the installation, so penetrating through the roof membrane. A lot of suppliers now have design or products that will weld onto the membrane, and so that you're not fixing through it. And it also offers the same or strength with regards to wind loads and things like that, actually holding the panel onto the roof. So a lot of suppliers are now recognizing that, because solar is a big issue with regards to waterproofing penetrations in there. From Good Earth's point of view, do you want to talk about measuring some of the things you do with solar, Lorenzo, on a roof?
Yeah, look, so for us, we obviously, with the solar for apartment residents rebate that's come into play, we've been approached by a lot of strata trying to investigate, putting solar on the roof. And often the first step is we can't go any further if there isn't any membrane on the roof, or if there's a membrane. The last thing we want to do is come in and actually do a penetration through the existing membrane. So obviously we don't do that, and we're limited with the options. So either, as you said, we either have to wait until a company like yourself comes in and is redoing the waterproofing. So we've had quite a few projects where they're saying, well, in 18 months we've got the budget together and we're going to start doing the membrane. We sort of have to wait until they're at that point so that we can, like you said, do that welded method where we put the anchors down and it's all welded in and sealed with the membrane, and then we can come in and put the racking system below. Our other alternative is to go over the top of an existing system and just use a weighted, a ballasted racking system, which we get engineered to go in. But yeah, so there's a lot of strata that want to proceed and move forward with solar, but we can't do it until we know we have a safe roof to work on. So that can be a limitation for a lot of stratas, and it's very frustrating for everyone involved, because they're like, we've got funding here, we can get a rebate, but until we get that sorted, we don't want to touch the roof to create penetrations that are not sealed.
Yeah, gotcha. That's part of the issue. What we also see, they actually go ahead and do the solar, but not realizing the remaining lifespan of their roofing membrane. So then they get the solar done, and then the membrane fails after they've done the solar. And then it's even more difficult to actually properly waterproof the roof once they've installed the solar. So that's another challenge where we try, and you would do the same, is trying to educate the owners that they have to look at it holistically. They have to look at the problem holistically, and then look at, if we're going to do the roof, do it properly and get a good membrane, and then the membrane will outlast the solar panel.
Yeah, that's right. And look, we've worked with you guys on a couple of projects where you've come in to do the waterproofing, and we've needed to disconnect all the existing panels, and we've done one where there's the hot water systems and all they need to get relocated. You come through, do the waterproofing, and then we come and reinstate it all back afterwards, so that everything keeps running is going. So it's important to make sure that you can work in with the waterproofing team in those processes.
Yeah, and the what also that sort of gets missed with the waterproofing and roofing design is all the HVAC equipment. So if the owners are considering this type of remediation on roofing, think about also the equipment and the HVAC equipment. Can we improve that when we do the roofing project as well? Which you can talk to this as well. I'll let you run with this one.
Oh yeah, well I guess the key thing is if you're doing the waterproofing and everyone forgets to do around all the compressors and the outdoor units, it's a pointless exercise because you haven't actually waterproofed around where there's probably more likely a lot more access ingress points for water. So
yeah, and what about the Lorenzo with regards to things like gas and electric heating and things like that like owners considering when you're looking at a project, some of the things they should be considering?
Well, one of the big ones at the moment is everyone wants to get off gas. So when we've got a gas hot water system on a building, we're often looking at how do we put a heat pump hot water system in. There's a lot of things that come into play there. So the gas usually takes up a smaller footprint than the heat pump systems do. So we have to consider, is there enough room up there? Can the roof take the load of the bigger tanks as opposed to like an instantaneous gas system? And will that be waterproofed? I think we were chatting about one of the projects you've got coming up where we spoke about a project where there was a whole heap of existing electric tanks which would need to get disconnected, the waterproofing done, and then reconnected. And it's at that point in time that we're like, well, guys, if you're going to reinstate the old technology, there's rebates to put in more efficient technology. So the heat pumps, if you have existing electric tanks, the heat pumps are about 80% more efficient. So there's a huge efficiency that can be gained by putting heat pumps in. And, if you're going to spend all that money removing the equipment, moving it across, get the waterproofing done, and then reinstate the old stuff, at that point in time, it's probably not much more money to actually put a brand new heat pump system that's going to have longer warranties and it's going to have a longer lifespan and save significant amounts of money. So they're definitely conversations that need to be had at that point. Like you said, having that holistic conversation to go, well, we're up there fixing the roof and the waterproofing membrane. Have we considered what savings can be had by updating the tech? Air conditioners, if you've got old plant equipment up on the roof and they're using the old gases, they're often not variable speed drives. And so the efficiencies that can be gained just by updating the aircon in that same instance, you can be looking at 25 to 40% power savings by putting in, modern air conditioners that use better gases. They've got variable speed drives, they're just all around a lot more efficient. So, if you're going to spend the money to relocate everything and put something in that potentially has another couple of years life in it, it's definitely the right time to consider upgrading at the same time.
Awesome. Thanks, Lorenzo. So a quick summary, key takeaways. So solar reflective index, if you can get membranes that are above 80 on a low slope roof, you're doing well. So looking at those PVC type or like a high reflective membrane. And then like we mentioned, thinking holistically on the design of the roof. If it's leaking, look at what can we do as an advantage to actually, if we're going to spend the money, look at what's on the roof, and can we insulate it, or can we get benefits on doing it right, and then having that system benefit the building in the long term. The other thing is, once that's all done, it's important to ensure that you're maintaining the SRI of the membrane. So inspecting it and cleaning it at least annually. And then, in summary, obviously dry sealed buildings are the most energy efficient. So keeping the water off that slab, on the roof slab, is critical for energy efficiency. we've gone a little bit. We've got about 5 minutes. So if you want to post in some questions into the chat, where Lorenzo and I are happy to answer. Obviously if we can't answer them now, we'll reply and get back to you. But I know we've got one question that's been posted in is it essential to remove the old failed waterproofing and then can the new waterproofing go over the top? So that's a good question. So in some situations, yes, it can. It depends on what is on the existing slab. The second thing is whether is the engineer or consultant who does the design, regulated design. If it's on, this is in a residential situation, on a strata situation, they would have to be comfortable with the design without ripping up the old membrane. So hopefully that answers the question. Happy to, if you want to, you can unmute as well if you want to ask a question as well. There's not as many of us in here, so we can probably if anyone wants to ask further question. From Tina. So thanks, Tina. So does Good Earth Group or Danrae have an engineer on board? So for our business, we don't have an internal engineer. However, we work with many engineers that actually do the design. So that is it's quite easy to get a design done from that perspective. I'm not sure about you, Lorenzo, what from an engineering.
Yeah, the engineering, we don't have one in-house, but essentially if it's a solar design and we're down close to the water and we need a design, there's 2 or 3 main solar racking companies in Australia. So Clenergy and Schledder are the 2 main companies that do solar racking, and they've got in-house engineer teams. So we will put it over to them to actually ensure that we've got a compliant design for the wind loading, because the wind loading is the factor. It's not usually a weight issue. It's actually a wind uplift issue. So the engineers need to make sure that it's going to comply with that. So the last thing any of us want is panels flying around the wind, especially with a windy day that we're having today. So
definitely.
We rely on external engineers in those instances.
Yeah. No. Anyone else got some questions for us that'd like to ask? All good. All right. Well, I think we'll wrap it up. So a big thank you to everyone that joined. Really appreciate you joining us for today. Look out for the next one. That'll be happening end of July. We'll be doing another webinar. And big thanks to Lorenzo from Good Earth Group. Thanks for your input, Lorenzo. Love working with you, mate, and thank you so much for your help. So thanks a lot.
Thanks for having me on.